So what's the hold up on ground source heat pumps and our goal to gain industry insight? So I guess it's no secret we need to fast track the world's journey to net zero and slow and reverse the effect of climate change. And with the heating and cooling of our buildings contributing such a significant amount to our carbon footprint. In fact, carbon emissions from heating and cooling of our built environment in the UK represent around about 25% of our emissions. So that's coming from the Green Building Council. So really with this imperative, we wanted to dive deeper into what the holdup is on ground source heat pump adoption, specifically from those involved with GSHP projects on a week-to-week basis. We know there is a holdup. We can see stats from 2022, for example, 620,000 heat pumps were sold in France versus 55,000 in the UK. So there's a significant difference between what we're doing in the UK and other countries around Europe and further around the world. Now, beyond this, we also wanted to really establish what are the key drivers so that we and all those involved with day-to-day stakeholder conversations can be clear about the main motivators to ground source heat pump adoption. There are always deep discussions, I believe, with people on this call and within Genius Energy Lab about these two areas. So we really hope that this session helps to better equip everyone with the information needed to help continue to drive ground source heat pump adoption. So the survey was sent out to key industry individuals earlier this year. We really took some time to look at those results and bring our thoughts together. And this session really walks through the main findings and then Genius Energy Lab's thoughts on those areas really as ground source heat pump experts. So from here on out, I'll hand over to Duncan, who's going to discuss the first major barrier that was identified in this. And yeah, hand on over. Duncan, I'll leave you to take away on the next slide.
Thank you, Andy. So yes, the barrier one was the cost dilemma. So one of the most significant findings from our study was the concern over the high upfront cost of ground source heat pumps. Many survey respondents felt that ground source systems are just too expensive, particularly when compared to alternatives like air source heat pumps. And it's not just about installation. There's additional costs associated with ground source heat pumps like borehole testing to assess the energy potential, which, as one respondent put it, can undermine the strength of the project if not done. It's easy to see why cost would be a sticking point, especially when projects have tight budgets or deadlines. Ground source heat pumps are often perceived as being more complicated and time consuming than other heating systems, adding to the hesitation. But here's where we need to shift the conversation. Ground source heat pumps aren't just an upfront cost, they're a long-term investment. Their operational efficiencies lead to significant savings throughout their whole life cycle, making them one of the most cost-effective heating solutions available today. To really understand this, it's important to look at the whole life cycle cost calculations. Whilst ground source heat pumps require higher initial outlay, their running costs are significantly lower over time thanks to their superior energy efficiency. For example, the ground source heat pumps themselves typically last 20 to 25 years, and the ground loop is a long-term asset of well over 100 years. And the savings a ground source heat pump system generates more than offset the higher upfront costs. In addition, the upfront cost of both commercial and multi-residential projects must be considered holistically. For example, the cost of additional electrical infrastructure that is required for a less efficient air source heat pump solution is often greater than the cost of the boreholes themselves. Also, when you consider prime real estate, such as in London, the additional revenue that can be generated by liberating high-level or rooftop space by removing plant required for air source heat pumps can be very attractive and a lucrative motivator towards a ground source heat pump solution. Finally, now there are numerous business models being created to completely fund the required capex of a ground source heat pump system so that it can be owned and operated as an asset in the long term. I will hand over to Chris.
Fantastic, thank you, Duncan. So if we can look now at the second barrier that was raised in the questionnaire, lack of awareness and misconceptions. So another key piece of the feedback that we had was the understanding surrounding ground source heat pump technology. About 40% of our respondents pointed out there's still a considerable gap in knowledge, especially among builders and architects. Now, this can lead to decisions based solely on initial investment costs rather than a full assessment of long-term savings. And in fact, it can be even worse than that, in that the perception of ground source as being a risky proposition can lead it to be often willfully ruled out of a project when it's actually entirely viable. So these misconceptions also extend to the complexity of the installation, and that again adds to the hesitation. So many in the construction industry don't realise that most ground source installations are actually classified as permitted development, meaning that planning permission isn't always required. And there's a lack of clarity that can stall projects, especially in regions where planning guidelines are interpreted differently. That's one key element in the lobbying environment that the Ground Source Heat Pump Association are working on at the moment, is to unify and to get consistency amongst different planning areas. So this is where our education comes in. Genius Energy Lab is out to simplify ground source heat pump adoption by providing targeted and accessible information to industry professionals. So our monthly newsletter, hopefully you're subscribed to that, The Source. We do aim to deliver learning every month in that newsletter. We also do a very successful Lunch and Learn series. We get fantastic responses back and feedback on our Lunch and Learn series. So if you are interested in a dedicated hour presentation to your practice about the technology, then we're more than happy to do that for you. I'd also say it's not death by PowerPoint. It's a very interactive whiteboard session that we host. And as I say, it makes it very enjoyable as well as very valuable to those who are coming in. Final point I'd mention on awareness and misconceptions is seasonal COPs and COPs. So coefficient of performance is how much heat do I get delivered into my building divided by the electrical consumption. The COP, the coefficient of performance, is at a given point. So for air source, that's 7-degree air temperature and 35-degree water temperature. For ground source, it's actually 0-degree water temperature in the source and 35-degree on the load. So ground source at the rating point is being asked to work harder. It's lifting heat from 0 degrees to 35, as opposed to 7 degrees to 35 for air source. So COP isn't a fair comparator between the two technologies. So what is? Well, that's seasonal coefficient of performance. So that's the annual heat delivered divided by the annual electrical consumption. Now, from a ground source point of view, actually modelling that and predicting that is relatively straightforward. As part of the ground source design process, ground loop design process, we will actually do, if we're given hourly load data, we can give you hourly temperature data back for that ground loop along with consumption. So we can model it very, very accurately on a seasonal basis. Slightly more challenging from an air source point of view, because particularly in our climate here in the UK, we've got a maritime climate. It never gets cold enough really that the air dries up as it does in Central European, Scandinavian countries. And what that means is that damp air is condensing on the coils of the air source, and that condensate then freezes. So you have to defrost the machines, and that can dramatically affect the efficiency of an air source product. Go on to the next slide. So the third barrier, as was noted in our survey, it's not just the complexity it's holding back ground source adoption, but also lack of government funding. That was seen as playing a significant role. So our respondents highlighted the need for more innovative funding solutions to make these systems more accessible. This is something we've seen mirrored in recent reports like the one from E3G. I would really encourage you to follow that campaign. They're really ripping up trees as far as electrification of heat is concerned. And that's all about emphasising the lowering of the upfront costs of sustainable energy technologies. There is some good news on the horizon, however, from an incentive point of view. 30th of September, Department for Energy Security and Net Zero launched Warm Homes, a social housing fund aimed at making millions of social homes more energy efficient by 2028. Through this initiative, we're partnering with Kenza particularly to help social housing landlords adopt ground source heat pumps and access much needed funding. But really, what I'm here to say is funding isn't the only game in town. As an industry, if we're going to grow sustainably over the years and create a self-sustaining industry, then we really need to transition away from grants as a mainstream reason for adoption. And what this is really is a call to industry for action, and it's around innovative funding mechanisms. As Duncan mentioned earlier on, we can look at third-party funding of ground loops. That's treating ground loops just like gas pipe used to be treated, just like water pipe, electricity cables, broadband cables, and so on are treated, in that they're not paid for by a housing developer, for example. They're paid for by a third party, which then will sweat that asset over the long term. 50 years is typical. And that revolutionises the economics of ground source as an installation of the technology. And in actual fact, it can make the installation of ground source at a district scale for multi-residential cost competitive or even cheaper than a air source alternative. And back to the point that Duncan made earlier on, the boxes last a lot longer and the ground loops are going to be there for 100 years or more. So it's really a long-term asset. And it's this transition away from government handouts towards a much more commercial and therefore sustainable model. And this is not the future. This is actually happening now. The number of projects that we've got based on this type of model is increasing every day. If I can have the next slide, please. Motivating ground source heat pump adoption. Well, carbon emission reduction is a key part of it, as well as lowering costs and energy security as well. So while barriers exist, it's important to remember that there are these strong motivators driving the uptake of ground source heat pump technology. The most significant factor is really the potential to reduce emissions. Around 33% of our survey respondents cited this as a top motivator for looking at ground source. And that demonstrates how ground source align with the corporate commitments, social environmental responsibility commitments that many organisations are now making. And it's really refreshing to hear that large developers are now targeting embodied carbon and operational target carbon as the main priority in any development. And another major incentive, as I said, is the long-term run cost savings. Despite the initial outlay, the low run cost savings, the low running costs and long lifespan of ground source makes them an attractive option for the bigger financial picture. So many respondents recognised that ground source offer the lowest total cost of ownership, which shows a growing real maturity in the market's understanding of the technology. And then finally, energy security. It really is a key motivator for us now. So 20% of respondents highlighted the need for stable and reliable energy sources. And ground source heat pumps are increasingly an attractive option. So their ability to provide the consistent heating and cooling regardless of external energy supply fluctuations gives them an edge in today's volatile energy market. I'll now hand over to, is it Rich now, or you Duncan? For the Q&A.
I think it might have been Andy, but
Andy, apologies, sorry.
That's all right. Looking at the chat, I don't think we've had any questions come in, Andy. If anyone does have any questions, please feel free to pop them in the chat or raise your hand. Yeah, we've got a question here from David. Can we unmute David's mic, or are we?
I think we might be limited to working.
We may be limited, David. If we can't unmute you, please drop it into the chat and we will definitely answer it for you.
So I think one question from myself, Chris, while you were talking through a couple of those barriers, was really in relation to the misconceptions. So if I look at barrier 2, misconceptions, I know in conversations I've had with yourself that there are various that exist, from turning up on the doorstep of an older building and looking at that construction site and thinking straight away, well, ground.
Got a bit of interference.
That you've come up with.
Yeah, we lost you slightly there, Andy.
Sorry, Chris, I think I might be back. So
yeah,
are you able to talk us through a couple of examples that really stick in your mind as to misconceptions that have come up that are really more commonplace that you're handling, I guess, more and more in 2024?
Yeah, Certainly. So I think that perhaps the most common misconception is the space that's required for ground source. And that's one of the most common misconceptions. So I'll give an example of a multi-megawatt business park, new build business park, and the team had written off ground source on the basis that they couldn't fit enough horizontal trenches in to do that system of that size. Multi-megawatt system's never going to be horizontal trenches. It's always going to be boreholes. And so they were overestimating the amount of space that was required by factors of 10. In fact, it was actually worse because there was a big ornamental lake in the middle of that business park, which would have made a fantastic source. So I think that's one of the key misconceptions, is the space required. I think other misconceptions, lots of geological objections will be put up against ground source. So I've heard people say, oh, we've got hard rock, we've got soft rock, we've got source protection zones, we've got coal mines, all of these other reasons why geologically there's going to be a barrier to doing ground source. And I think with proper geological investigation, the number of projects we actually write off from a geological point of view in a year, you can count in fingers of one hand. It is very, very unusual to see a geological problem on a system. So yeah, lots of misconceptions around what ground source, and indeed some of them are actually willful. So people are seeing ground source as risky, and so they want to get rid of it. They want to get it off the table. And a great example of that, and a customer that's really stuck to their guns, is the Department for Education, who have listed ground source at the top of the hierarchy of their solutions for decarbonising schools. We're doing a huge number of them at the moment. And that's really to do with the Department for Education sticking to its guns, as I say, and saying, no, you've got to, if you can't do ground source, you've got to justify why you can't do ground source and give us some real reasons as to why you can't. It does happen, but it's not very common that you can't.
Lovely. Thanks, you, Chris.
I think I've managed to unmute David. So David, if you'd like to ask your question.
I'm sorry, it was really only to say that the chat isn't available.
Oh, okay.
Anybody to upload questions. Yeah, and sorry, that's really all. But I do wonder about the relevance of your points when it comes to retrofit. Or are you talking, retrofit applications as well as new build applications?
Yeah, David. I mean, it's difficult to gauge just right at the minute because there's so much going on in the marketplace. What percentage would be retrofit and what would be new build? What I would say is I've got some good numbers going back maybe 4 or 5 years, and the vast majority of what we were doing was retrofit at that time, because that was the market conditions that were prevailing at the time. Now, what I would also say is that if you, as a lot of politicians often think, and civil servants tend to think about individual owner occupier, and if you start to roll out ground source at scale for individual owner occupier dwellings, that's a massively expensive proposition. I put a borehole in my garden, and then 2 years later my next door neighbour does the same. That's 2 mobilisations of drill rigs. It's just not economic. Whereas if we start to look at the world on a street by street, town by town basis, as we increasingly are, then that not only brings in the new build housing market, which is obviously a huge prize for decarbonisation, but it also brings into focus really the retrofit market. And we're doing work at the minute on a street in Chelsea, in London.
In Chelsea?
In Chelsea, in central London. So, it can't, now I'm not saying that's easy. Don't get me wrong, I'm not saying that's without its challenges, but it can be done. And increasingly we're doing these retrofit multi-residential solutions. Yeah, great question, David. Thank you very much indeed.
Lovely.
I see
we have got a
couple
of questions in the chat, Chris.
I see that now, yeah.
So in 2025, what do you think is the #1 ground source heat pump message to governments?
Well, I think that consistency is the key thing, that their continual ask in the policy environment is please be consistent. So when is the future home standard going to be adopted? When is the boiler phase out going to happen? Those types of consistency will signal to the marketplace. Now, a lot of those conversations are already impacting the marketplace. So we are seeing developers increasingly seeing gas being installed now as a stranded asset. They're looking at heat pumps and air source and ground source, of course, as well. So I think that's the real message, is government, please be consistent in what you're looking to achieve and set those pathways out. Because as I mentioned earlier on, third-party ownership of ground loops. It's all about investment. It's all about the big pension funds and companies like that who are looking for these long-term investment opportunities, and they can't commit to it without that consistency in the policy environment. So I think that's a key message, I would say.
Yeah, there's a follow-up to that. How much do you think the European and UK in particular market will grow, and which country is growing most rapidly worldwide?
It's a very interesting question. It's so dynamic at the moment. There are market forces operating in the UK that could catapult us beyond France in 2 years' time. You know, they really could see, you know, that tenfold increase in installations happening. That's new build infrastructure for houses, particularly. You know, that's a multi-thousand unit a year opportunity that could, as I say, transform the industry. So we're kind of at this unusual junction point, if you like, where we're starting from a low base, but the drivers, the tailwinds for the marketplace are absolutely huge. So France has done well recently. Obviously, there's a traditional Scandinavian market. North America is doing quite well at the moment, very regional in North America, with different states having different policies and so on. So it's incredibly difficult to crystal ball. We are picking up work virtually all over the world now, from New Zealand, South America, North America, and everywhere else. So what's good about our company, we tend to get involved in projects quite early on in the gestation cycle by doing feasibility study work for them, for example, and that is a good indicator for market, the market development. And we are seeing these bubbles coming up all around the world. So not a straight answer. I'm really sorry, because I really don't know the answer, because I think these market dynamics are so interesting at the minute that they could just change any given market overnight almost.
I think the potential boom that is on the very near horizon, from my perspective, that's going to lead to some interesting bottlenecks, which you might want to talk about, Chris.
Yeah, I mean, obviously, there are a number of components involved in ground source. So heat pumps, obviously, pipe is another key component. Polyethylene pipe is what we put in the ground. Then there's skills, which is a key bottleneck at the moment. So there's an apprenticeship program that the Ground Source Heat Pump Association is just launching at the moment. Most of the manufacturers will undertake training. The microgeneration certification scheme has just launched its over a year now, launched its microgeneration certification scheme for drilling contractors, and that is improving the standards in the industry, along with things like audits that the Ground Source Heat Pump Association are undertaking of drilling contractors. So we've got bottlenecks. We've got to recognise those bottlenecks, but there is an investment opportunity. You know, drill rigs are £500,000 to £1 million a piece, and the operators take a lot of training to operate them safely and effectively. So, you know, there are challenges in the marketplace that are worth considering. I don't see heat pump manufacture particularly as being a problem. It's a commoditized market. Air source, air conditioning in cars, fridges, everything else, your commonplace articles. And as ground source grows, the investment in that R&D for ground source will increase. So, yeah.
Do we know how many ground source heat pump systems are installed each year in the UK? And is the number growing?
Yeah, the number is growing. And as I say, we're at this junction point in the industry where almost overnight we could see many multipliers on the volume going on in ground source. Just have a look at the partnership between BU UK and Kenza, for example. That is a needle shifter on it. Andy, it'd be interesting to get your take on that as well.
Yes.
I'm putting you in the spot,
Chris.
have I?
You have. I was just checking questions in the Q&A. I'm so sorry.
Yeah, I mean, your thoughts about, you know, the growth of the marketplace, really, from a ground source point of view.
Absolutely. I think from what we're seeing, when I look at it from a marketing perspective, and I think about some of the stats that I'm looking at on a month-by-month basis, when I look at the conversations that are happening, one of the things we do on the marketing side of things in the ground source heat pump space is look at what's called maybe the noise, the chatter, the conversations that are happening, that are turning up on LinkedIn, the different articles, when we're thinking about tracking searches on, say, Google, how many people are typing in ground source heat pump boreholes into the Google search box every month. All of those stats in the UK are driving upwards. It is getting into our minds and into the conversation around renewable energy a huge amount more. I mean, we've obviously seen the adoption curve when it comes to solar PV, batteries. We've seen that adoption moving forward, and I think that similar adoption is happening with ground source heat pumps and with heat pumps overall. We've got a huge amount of pressure from stats that we're seeing in Europe, to conversations like this that are happening with people turning up into these forums to listen and be a part of these conversations. This wasn't happening 3 years ago. So absolutely.
Yeah, that's fantastic, Andy. Thank you. Sorry to put you on the spot. A question just come in the chat. Thank you, Robin, for saying it was a great talk. Thank you. 2 questions that Robin's got. One is, what's the standard distance between abstraction and re-injection well for an open loop system? So open loop, for those of you who don't know, is when you use a pair of water wells. You take water from one well and put it down the other. And one of the most vexed questions is, how far apart do those need to be? The standard answer is 100 meters, but it can be less and it can be more depending on the character of the aquifer. But if you want a guide, 100 meters between an obstruction and a recharge well is going to keep you on the straight and narrow. And do you see fears of sterilising a site as a barrier? Absolutely. The installation of closed and particularly open loop has an impact on quite a wide area. So if I were a building owner in central London, I'd really be thinking about getting as many water wells installed as I can, because when you get your license from the Environment Agency to operate those wells, that's a protection that you've got for that well, statutory protection you've got for that well. So it's an opportunity at the moment to decarbonise big chunks of the city with open loop water wells. So we're doing a lot of open loop systems at the minute. It's fair to say the Environment Agency are very, very busy at the moment. We did yesterday our Ground Source Heat Pump Association regular consultation meeting with the Environment Agency, where we highlighted all sorts of issues on both sides, really. Some opportunities, but yeah, they are very busy. So to get water wells in, and in a thoughtful way, I think is one of the challenges for the big city centres. Manchester, should also mention as well, has got a very big aquifer. Birmingham. Most big cities have actually got a big aquifer, or it wouldn't be a big city. It's one of the things that constrains growth in a metropolis is water availability, and because London, Birmingham, Manchester and so on have got these big aquifers, that's one of the reasons that growth in those cities was fuelled.
Chris, I've got an additional question that's come in from Simon Todd on the Q&A. I think this is a really good question around, do you have a view on the impact of the UK's much higher electricity prices compared to Europe?
Yes, very much so. So background, and I'm sure, Simon, you know exactly all of this, so I'm just hopefully filling in for those who don't know. But historically, there have been environmental levies put on electricity to fund environmental measures. There is a discussion now that wasn't going on 2 or 3 years ago, but there is a discussion now about rebalancing those tariffs and potentially then removing them from electricity price, potentially putting them on gas, but that is an incredibly difficult political hot potato. The fact that they're talking about it, politicians are talking about it now, is a massive move forward, but that's a long, long way away from doing something for it. So yeah, it does have a big impact. I see it particularly when I'm doing cost appraisals and run cost saving appraisals for buildings with heating only and heating and cooling. So when you're benchmarking a heating only system against gas, in a house, you're probably going to be about break even run cost wise. when you pull heating and cooling in there, because your counterfactual fuel in both instances is electricity, it transforms the economics of the system. So you do see it when you're doing feasibility studies like that. You know, ultimately though, we all know that electricity, we've got very strong decarbonisation targets, and the cost should come down along with that decarbonisation, because we're harvesting, you know, free solar energy, free wind, and so on. So it's a long-term view again you've got to take. But no, currently the fuel prices aren't particularly helpful for us.
I think another aspect that might be interesting to talk about in this particular question as well is potentially for bigger commercial projects where you might be looking to combine ground source heat pump with solar PV, and the innovation that is happening with PVT.
Yeah, it's a really interesting. I mean, we are obviously asked to hybridize systems all the time. Ground source tends to be the core of it, and then we'll pull in other technologies to meet demand. So working in a private school down in the south of England at the moment, where a large solar PV farm along with ground source is the solution that they're looking to put in there. When you turn to solar PVT, so it's a PV panel with a solar thermal panel bonded to the back of it, you can then use that solar thermal panel to recharge the ground loop. So we can put heat back into that ground loop and improve the efficiency and potentially reduce the amount of ground loop required, because we're recharging the battery. We're putting that heat back in again. And there's another good win, because you're cooling the back of those PV panels. You're actually increasing the solar electrical generation as well. So it's a really nice win-win. And we've got installations going back about 4 or 5 years now. With data on that are allowing us to model these things in more and more detail all the time, and it's becoming an increasingly common solution for schools as well, particularly retrofit schools. So yeah, quite a nice hybrid coming along there.
Yeah, definitely. One further aspect on the cost side to mention that I'm keen to highlight, because there's definitely some recent projects that have bumped into this, is the cost of ground source heat pumps, the implementation of this, it can increase if it's not being considered early in the project. And where a project has moved forward, all of the planning has happened, and then ground source heat pump is a afterthought. There's been a review of how we're going to heat and cool this building, where you're then having to re-engineer the process of bringing ground source heat pumps into the planning phase. Obviously is going to take a bit more time and consideration as to how you're doing that. But also, I think where it's a last minute thought, where we need to shoehorn this technology in, that often is where a lot of these misconceptions can come from, because it causes a lot of pain in a project.
Yeah.
You end up with the contractors thinking, well, we had these timelines to achieve and to hit, and now we're bringing in this technology, and we're having to think about bringing the drilling rigs along to put the boreholes in the ground, and that's going to slow us hitting our expected deadlines. That obviously causes issues, you know, in the construction sector, where there's a difference in the view of how this technology is to work with. So I wonder if that could be something to talk about also, Chris.
Yeah, definitely. Yeah, definitely. It really is worth considering. The best projects that we get involved in, we're involved at REBA stage 1, 2, and we're planning the ground source adoption right the way through that, and they tend to be the projects that go in smoothest. Whereas if you are, as you say, shoehorning it in at the last minute, all sorts of decisions will have been made. What distribution temperatures are you running at, for example? That might be cast in stone by the time we're even consulted on it, and we could have maybe massaged that distribution temperature down a bit. We can't now, because it's all committed to, and we've compromised the lifetime efficiency of that solution by making that decision. So all sorts of reasons why it's good to plan these things in advance. And what's really good about the way we do our feasibility studies is we are able to de-risk that at that very early stage. So when we do a feasibility study, we'll be looking at the geology from a desktop point of view, we'll be looking at the ground loop design, and we use exactly the same process, even a REBA 1, REBA 2 feasibility study, exactly the same design process as we'd use for a final design on a project. So all things being equal, and of course they never really are, but hey, all things being equal, we should have a viable solution right from day one of the project. So we're not going to get a nasty surprise and all of a sudden what we thought was going to be 30 boreholes is now 50 boreholes. We know exactly where it is.
Yeah.
I'm conscious we've got a hand up from one of the audience.
Yeah, I think I can liven the mic up for Nigel. Is it Nigel still got your hand up?
Yeah.
Should be able to speak away.
And then Joe?
I think Nigel will need to unmute himself now.
Yeah.
While Nigel is unmuting
Okay,
himself.
I'm here.
Oh, sorry.
Oh, hi, Nigel.
Hi, Nigel.
You mentioned something that changed ground source heat pumps overnight. Was the Kenza and someone else news?
Yeah,
What was that?
BU UK. So BU UK put in about 60% of the utility connections for new build houses in the UK. And, you know, so I'm a developer. I've got planning permission for 2,500 houses. Traditionally, I wouldn't have expected to pay for the water connections, the electricity connections, and so on, the utility connections for those properties. A company like BU UK, and there are others out there, would come along and do that for you. And they've adopted ground loops as the same utility model now. And that, Nigel, it's a game changer, as you can imagine. You were talking about 600,000 new houses a year, I think, if my memory serves me right. And, you know, as I say, BU UK are doing something like 60% of those new connections. We are literally doing many projects a day in terms of initial analysis on that. And, you know, when they start to go into installation, it's a game changer completely.
Will they promote that nationally when they're doing it, or they are promoting it already? It's just not known.
They are promoting it. I mean, BU UK is one of these companies. It's what, you know, it's the biggest company you've never heard of, sort of thing. It's one of those. They have got other divisions like Metropolitan, who are district heat operators, networks, and so on. But yeah, they are promoting it nationally. It tends to not be public promotion, though. It tends to be, you know, going to Bellway Homes and going to
Developers,
all the others, yeah, and saying, look, we can do this for you. So it helps them with a planning permission. It helps them with the, you know, external placement of air source, getting rid of that. And what we've developed with the partners in the team on the project is a very familiar experience for both BU UK and for the developers themselves. So they've got something that really is the gas pipe of the future, if you like.
It's
It's
a very
tangible
interesting
and
sales
they roll it out.
proposition.
Sorry, Nigel?
Yeah, so it's just a standard sort of template for them. They just roll it out to the developer if they want it.
Yeah, exactly. They're a very dynamic business, BU UK, and we along with Kenza, we've had to work really hard on internal automations and processes to keep up with them because they move so quick. And that's the industry they're in, you know, and they've got these processes have been finely honed over many years that we're now plugging into and making it, as I say, as familiar an experience for everybody in the supply chain.
If you
Okay,
nip over
thanks.
to Kenza's LinkedIn page, there's several articles that they've posted on the relationship, and also BU UK have posted several articles on LinkedIn as well. If you want to do a bit more research on that, Nigel.
Lovely. I'll do that.
Sorry, Doug, sorry.
I was just going to add, it's a very interesting sales proposition where they are leading with the opportunity that a developer can offer active cooling in a bedroom, for example, because one of the key benefits of having a ground source heat pump system is that they do very efficient cooling, and the more cooling that is actually used, the better the efficiency for the heating will be come the following winter, because of the ground interseasonally storing the energy.
Right.
I've
Kenza
just-
doing the geothermals with the reverse heating and cooling switch now.
So at the minute, Kenza's own heat pump product line are non-reversible units. They do have passive cooling modules on them, and they also do install reversible heat pumps from other manufacturers who've got framework agreements with them as well. So all of the above, Nigel, they can do now for it. And increasingly, these big city centre multi-storey apartment buildings that we're working on, lots of them now, they're actually cooling dominated, these buildings now. So we're doing 3 in central London at the minute, all of which are cooling dominated in those loops. I've had an email come in from Ruth Cunningham, who's struggling to get some to type in the chat. So apologies for that, Ruth. She's asked for what is the limitation of ground source heat pumps. It's a very interesting question. I mean, all the stuff that we've talked about above. Is it right for every project? No. I think if your only driver is initial cost, as some projects are, then probably ground source isn't the right solution for you. So that would be a key limitation of ground source. I think knowledge, as we mentioned earlier, is a limitation of the technology. We do a lot of education. If you're interested, the Ground Source Heat Pump Association's got a course of 17 bite-sized sessions that you can sign up to. There is a cost associated with it, but that's 17 sessions taking you from early days concepts on ground source right the way through to how do you interface with the supply chain, how do drilling contractors operate, all of these kind of things. Let's say they're 10 to 25-minute bite-sized sessions that have been available. So head on over to the Ground Source Heat Pump Association education website, and you'll be able to sign up for that program. It's proven to be very, very popular now. So as I say, education is a key limiting factor as well. But and again, okay, yes, there are projects we have to write off on the basis we don't have space. We have to do that. We occasionally have to write off projects, as we did was one in central London, looked really good, but there's just no water in that bit of London in the ground. So because we had limited space, open loop would have been a good solution, but we just couldn't access enough groundwater to do the job. So occasionally you do have those kind of limitations as well.
I think on that, Chris, the key is if you get in contact with us with an opportunity, we can have a quick look at that and give you a steer very early on, often before any investment's made sometimes. So don't be shy. Come and speak to us, and we'll give you a steer. But most of the time, it is viable. But there are occasions when it's not.
Yeah, absolutely. And we're always happy to take some emails, take a call, whatever on a project before even you might be engaged on a project. So we can have a conversation about it. Very often we'll have conversations with the consultant engineers or the developers or whatever, saying, are we barking up the wrong tree here with ground source? And we can answer those questions generally very, very quickly and free of charge. So I'm looking for questions. Anything else come in?
So there's one further question that I see in the Q&A, which is, there's 2 further questions actually. So there is one from Wayne. Why is the air source heat pump COP from 7 degrees, but GSHP is from 0 degrees?
Some very, very good lobbying by the air source industry going back about 20 years ago. That's basically it. They got the EN 14511 standard written at what is effectively an average air temperature and what is a minimum really ground loop temperature. Zeros are normal and minimum that will drive a ground loop down to. We do go a bit colder, but not that much colder. So yeah, good bit of lobbying. I remember sending the new standard over to, I was importing an American product into the UK at the time, and I remember sending it over to them, and they called me up and said, man, you've had your leg lifted there. And we had, as an industry. So yeah, it's not a fair playing field. So please think about seasonal rather than coefficient performance.
And then there's a final question from Pastor. I'm unsure if we'll be able to answer this one. So Pastor says hello from Hungary, from a GSHP design company. Says one interesting aspect that he's learned is prices of the drilling boreholes are quite different from country to country.
Yeah.
For example, as far as he knows, in Germany it could be more than 90 to 100 euro per meter, while in Scandinavia it's perhaps 30 to 40 euro per meter, and it depends on a lot of things. And he wondered, he's curious as what the price per meter is in the UK.
It's something that we actually benchmark, Pastor. Yes, thank you. It's a really good question. So what's different between the different markets to make the prices different, first of all? So you've got geological conditions. Scandinavia tends to have a relatively uniform geology. They can drill the hole, open hole as we call it, hang the U-tube in it, and that hole will fill up with water. So it's a cheaper installation. You don't tend to have as much construction as we do. We've got incredibly variable geology in the UK. It's quoted as being the most diverse geology anywhere in the world, and that's because how the British Isles were formed. The frozen bit in the north where I'm from started off life over in Newfoundland, and this bit I'm down here in England has always been connected to Europe. So it's a very diverse geology in the UK. So that does tend to affect the prices. So to answer your question directly, we are seeing prices as low as £35 a metre, up to 65, 75 pounds a metre, depending on where we are geologically. Are we in a city centre location? Are we putting boreholes under the building during construction? All of those kinds of things that will force costs up. But so it's a very wide range.
It can be higher than that in tight city centre project locations. Yeah, centre of London, it can be over £100 a metre.
I guess the other thing to mention, Chris, is whether or not you factor in the mobilisation charge, because so the per metre drilling cost is one thing, but then depending on how many boreholes that you're going to be drilling, the mobilisation can get sucked out, into that economies of scale. Yeah. So it's lots of levers to pull.
Lots of moving parts in that one, Pastor. It was a great question. So yes, lots of different things come into it. Fuel prices, for example, with the tragic war in Ukraine and so on, that drove prices up to a big spike for a period of time. Commodity prices as well, they use metals and things like that in these installations. So yeah, lots of moving parts in that one. And as you say, Rich, if you're going to site and installing 100 boreholes, that's a very different proposition to 10 boreholes, and again a very different proposition to 1,000 boreholes. So it's the economies of scale are absolutely everything. I did some analysis back in the day when I was in a contracting business, and I worked out the multiples of 3 drill rigs on a given site are the most efficient because they can share ancillaries between. So a lot of drillers will be in the bigger sites be deploying rigs in multiples of 3, sharing that ancillaries between them. So those kind of economies of scale are also huge, as well as mobilisation that you mentioned, Rich.
I think there's a really good project to mention from Kenza, which is the Heat the Streets project. I think there's some great examples of big commercial ground source heat pump projects and heat networks. But if you're I guess if you're an end user, a homeowner sitting at home thinking, okay, well, ground source heat pump might not apply to me at home on a single occupant situation, then I think that makes sense. But when you look at the Heat the Streets project from Kenza, that's a great example of a community coming together and working with Kenza to effectively put boreholes down the middle of the street and connect a number of houses into that as a retrofit. It's a great example for communities to look at, and requires a community champion to help have a conversation with someone like Genius Energy Lab or Kenza to find out more about how that happened, and build those economies of scale. So
yeah, you can't emphasize how important that community champion is, Andy. It's just pivotal to getting a project off the ground. A project I mentioned earlier on, working on in Chelsea, we've got a couple of residents there who are architects, and they are evangelical about the project going forward, and that's the reason why we are doing something that is very, very challenging in a congested city centre location. And all of a sudden, there's a end of life home, or late life, home on the site. They want to get involved, and they've got cash to put in because they've got a decarbonisation agenda, and all of these things just start to add together to make what seems like a really challenging installation become a real project. And Heat the Streets is a key part of that. If you want to have a look on again, Kens's website, there's a project called Stidians, which was the first one that we designed and they rolled out in that model.
Brilliant, Chris, thank you. So since we've been chatting, we have a couple more questions that have come in. We've got up until 2 o'clock, so I'll ask a few more if that's okay.
No, please.
So there's a great question from Yash. So Yash, then I'm unsure again as to our ability to strongly answer this one, but why are Asian countries perhaps not seeing the traction in ground source heat pumps, perhaps compared to European countries? Is there a thought on that?
Yeah, Yash, hi, hello in India. Good to hear from you, Yash. So yeah, it's interesting. It's very market specific. I think like China is a huge market for ground source because of their power problems that they've got over there. Traditionally, Korea has been a very big market for ground source. An ex-colleague of mine moved back to Malaysia a few years ago, couldn't sell a single system, just couldn't get out the starting blocks with it. It's very, very difficult to decide regionally. I mean, obviously, if you've got a climate that's just hot all the time, then it constrains the way that you're going to be designing these systems in different ways. Countries like the project we've worked on, Yash, where you've got the low winter temperatures because of the altitude, as well as that high summer temperatures, makes it more viable when you've got that heating and cooling going on. But you know, ground source has been installed everywhere from Death Valley in the US to Antarctica. So you know, it's viable everywhere. And I think there's much more to do with the political environment, how people feel about fuel, that corporate social responsibility agendas when they actually start to bite, when boards start to look at the design of a new building and start taking their embodied carbon, whole life carbon seriously, and are willing to put money towards doing that. So yeah.
I would add to that also, it would also depend on how advanced the setup of supply chains is in a particular country.
It's a really good point, Duncan. Yeah, absolutely. It can be challenging to get this technology into a new marketplace, perhaps where there's not been traditions of drilling, perhaps where there's not been traditions of heat pumps even. That could be quite challenging. But yeah, I've designed systems from all over the world, and it can be made to work technically. It's just whether the political and economics are there. Great question, Yash. Thank you.
Brilliant. Thank you, Chris. So we have a question from Fawad Ahmed. How do you suggest that current university graduates doing research on the ground source heat pump industry can actually get into the industry, can join?
Absolutely. Yeah, we are almost constantly recruiting. It keeps Rich very busy finding new talented engineers for us in our business. We are one of a number of design houses in the UK. There are obviously contracting businesses as well, which potentially would do their own design. We've got 6 in our engineering team at the moment, and we're looking at another 1 or 2 hires early next year as well. So by all means, get in touch with us. We are almost constantly looking for new talent to come into the industry. What I would say then is, you know, do as much research as you can. Find out as much as you can about the technology. There's some great public domain information out there. Consider investing in something like the Ground Source Heat Pump Association Stream 1 Learning I mentioned earlier on. So that's that 17 lecture series on ground source. That's a really good way of knowing what you're talking about getting into the industry. What we do is about 40% geology, about 40% hydraulics, and about 20% of how much pipe do I need to put in the ground to give the thermal transfer. So it gives you an idea about what the skill sets that we are employing in our business are. One of the most exciting things that we are as a company is we're effectively a technology company that happens to design ground source heat pump systems. And what I mean by that is we've got procedures, processes and tools in place by which we can take a good quality graduate in from university, and we can have them actually turning around paid design work within 3 to 6 weeks. So it's a steep learning curve, but you turn into a productive employee very, very quickly, which I think people find very rewarding. So yeah.
Brilliant, thank you, Chris. We have a interesting question from Donna Rossetti, which is, what are your thoughts on drilling with water compared to air drilling?
Interesting. So mud flush or water drilling is pretty much ubiquitous in most of the UK. In Scotland, they are fond of air drilling up there, and that's because of the geology that they've got up there. Some parts of Cornwall and so on, air flush, as it's called, is often useful as well. Obviously, if you've got coal mines, for example, you will be using mud flush or water flush because you don't want to heat the mines up and potentially set them on fire. So there are geological limitations to where you can't do air and mud flush. A lot of it is down to the equipment that the drilling company's got and the experience and the skills they've got. So as I say, up in Scotland, there's a big tradition of air flush drilling, which is less so down south. Just partly geology, partly equipment, partly just historics.
Okay, understood. Brilliant. Thank you, Chris. And then a final question in the Q&A at the moment is from Elliot Lipscomb. I'll try and convey this one clearly as I can. So if there was a change in design temperature for a GSHP ground array, and this was to increase, would this have an adverse effect on the CapEx cost if the ground array requirements would also increase?
Absolutely, yeah. So that would be a great question to ask when we do our lunch and learn. So please reach out to us and book a lunch and learn. That's a super question. So getting into ground loop design, it's all about the temperature difference you can create between the water inside your pipe and the ground around it, the general mass of earth, as we call it. The bigger that temperature difference, the bigger energy will be pushed out into the ground or sucked in from the ground. And by massaging those design temperatures, we absolutely can work that pipe per meter harder. The other point to make though on that is it's not a steady state design. It's not a peak design system. They're actually cumulative ground loops. So if you work them to a peak but longer, then you'll get less out of that ground loop than if you're switching that system on and off to the same peak. So there's quite a lot of subtlety to it. But yes, fundamentally, the bigger the temperature difference you've got between the water inside your pipe and the ground around, the more energy will flow.
Brilliant, Chris. Thank you so
much. Go
much.
into that in the lunch and learn, though. Yeah, absolutely.
Excellent. So I've checked I've checked the Q&A. I'm just looking at the chat. I am conscious that we're over, but Chris, if you're happy to answer any further questions that come through.
Yeah, no problem at all.
Just had Robin, great talk. Thanks. 2 questions. Is there a standard distance kept between abstract and reinjection system on wells for open loop GSHP system? And do you see the fear of, I think we've answered
that one earlier on, Andy. Yeah, I think, but yeah, brilliant. Second bit.
Okay, excellent. I think that's it.
Okay, cool.
Okay.
Just a mention of some of the resources we've got available to anyone that might be interested in them. On our website, you can download our commercial on-site guide, which has a whole heap of valuable information in. So if you haven't downloaded it, make your way over to the website and do so.
Great. Absolutely. Brilliant. So I think to wrap up, we've got, to conclude, while there are barriers to ground source heat pump adoption, we understand those barriers being upfront cost, lack of understanding, and funding solutions. The potential benefits of ground source heat pumps are huge. GSHPs offer substantial carbon reductions, low long-term costs for heating and cooling, and high energy efficiency. And the path forward is clear for us. Focus on education, improve funding solutions, and advocate for the technology's long-term value. Now, as more stakeholders become aware of the environmental and financial benefits of ground source heat pumps, we do expect to see wider adoption and at a faster rate. As Duncan's just mentioned on this final slide, There's a number of further resources from the white paper download. We have a blog that goes out every month. Lunch and learns are a key one that I think to reinforce. Book in for a lunch and learn for your organisation to understand a lot more about the technical aspects of the ground source heat pump, implementation, the technology, how it's being used in different projects around the UK and further afield. And finally, please do come and sign up to The Source, our kind of industry newsletter that goes out every month, keeping you up to date with the latest stats and insights and goings on at GEL, and give us a follow on LinkedIn. We'd love to hear from you there. So this is wrapping the session up a little bit past our deadline, but I hope it's been a very useful session for all. And I can't thank the Genius Energy Lab team enough for supporting this. Been a very great, very helpful session. So thank you all.
No, thank you, Andy.
Thanks,
And
Andy.
thanks, everybody.
Thanks, everyone, for joining.
Thanks for your questions.
Thank you.
Thanks all. Take care.